Present MultiSoft, a soft sensor enabling real-time multimodal sensing with contact localization and deformation. In this work, we propose a multimodal sensing pipeline which utilizes both computational method and learning-based algorithm. Previously, it was hard to learn sensor values for various deformations using piezoresistive soft sensor due to baseline shift and a long settlement after excitations. Here, we employ a calibration method for handling a temporal drift. In this way, we can maintain constant zero levels after every excitations, and train data with this will make the deformation classifier robust. Previously, real-time contact localization with stretching was introduced with carbon-filled elastomer. However, it is still challenging to maintain contact localization with deformations. With entitled deformation-aware capability with machine learning, we can form a deformation switch to properly update the time-varying distribution of conductivity change. In this way, we can keep up the localization under deformation and even after deformation. The sensor is in a form of multilayer where a base substrate is made of a highly stretchable and flexible silicone rubber. First, we fabricate a base substrate with physical molds. The curing takes between 30 to 75 minutes. Then, we directly apply carbon-filled rubber to the base substrate. Using a toaster oven, the curing can be done with 10 minutes at 65 degrees Celsius. By adding a new base substrate, the sensor becomes much more stretchable than a single volume carbon elastomer. Our test also shows that the sensor settlement after excitations is improved. Our sensor can learn the deformations instantly. Users are only required to perform each deformation once. Then, the prototype can classify different deformations, including stretch and bend. Our prototype can also learn the intensity of deformations. Our prototype loads classified deformations regression model for estimating intensity for corresponding deformations. Here, we demonstrate detecting the intensity of multiple bending gestures and a single stretching gesture. We form a stretchable gamepad with our prototype. Discrete button and different levels of stretching can be used for interactions. Users can utilize natural human motion like pulling for the input metaphor. Our sensor can be also attached to the flexible flip cover to embed bending interaction. Users can bend different locations of flip cover to launch different apps. Different level of bending can be used to change the intensity of continuous control. With high stretchability and flexibility, our sensor can support a wearable form factor. Users can contact distinct locations for launching different apps. Stretching can be used to support more secure interaction for reducing false trigger. A multi-level interaction is supported where a user stretches to trigger the function, stretches with different levels for scrolling options, and lift a contact finger to execute the function. We present MultiSoft, a multimodal sensing soft sensor that provides real-time contact localization, deformation classification, and deformation intensity estimation.